So we will start by finding the zeros and something called multiplicity. So the zeros are what? The x-intercepts. The zeros are when the function, the f of x equals 0, or this one's p of x. We're going to make 0 here, and we're going to solve. So we're going to say each factor, x plus 3, x minus 2, and x plus 1 equals 0. We're going to solve for each factor. So we get x equals negative 3, x equals positive 2, and x equals negative 1. Now the multiplicity means how many factors, how many of those factors had an answer that equaled negative 3? 1. How many factors had an answer that equaled 2? How many factors had an answer that equaled negative 1? So the multiplicity is 1. Because there's only one of each. Now then we go over and we look at this one. Oh, by the way, I'm going to change this one. Let's change it together. Get rid of that 4. It's not going to graph very nicely if the 4 is there. That's why I'm changing it. Just for when we graph it. I'm going to put a 1/50th instead. For real though. It makes a much better graph. Okay. So then we're going to find the zeros. So we're going to make f of x equals 0. Change color so we can tell the difference between the two answers. And then we're going to set each factor equal to 0. So which is the first factor that I'm going to set equal to 0? X plus 7. I'm not going to set the 1/50th equal to 0 because there isn't an x in it. We're trying to solve for x. So just start with the first factor that has an x, x plus 7. And then my other factor, x minus 3. So we get that x equals negative 7, and we get x equals positive 3. Is there a multiplicity? For x equals negative 7, how many factors does x equal negative 7? 2 of them, right. So we have a multiplicity of 2. And then for x equals 3, what's the multiplicity of that one? How many? 3, because that's the exponent. That tells you how many factors there are.
That's so it's going to go with how much is square of
The powers, yeah. So if I were to expand that, I would write 3 parentheses that said x minus 3. That's what to the third power means. So I'd have 3 of them. Now what does that do to the graphs? Let's discover what it does to the graphs by graphing it on our graphing calculator. Let's do the first one, the one I did in blue. Let's do that one. That is where all of them have a multiplicity of 1. We're going to type in our equation into y equals. When you go to graph it, if your graph is not a nice window, you can hit zoom 6 to fix your window. You're going to do this now, and then if your calculator's not graphing stuff, tell me immediately so I can fix the problem before halfway through class is over. Everybody get it? Something must have been wrong with your Be clear now, though? Yeah. Tell me if you have another problem. All right. So we are looking at this graph, and the graph at -3 passes straight through. What's happening to the function values, the y values? I'm not explaining this well. At this x-intercept right here. Let me just do it right. You guys have the picture in front of you, right? So the y values are negative, 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 then what happens when it passes through the x-axis? The y values are positive, positive, positive. And then it comes back around at some point, there's a turning point. And it goes back down and it passes through at 1. So the entire time that it is between -3 and -1, the y values are positive. Then what happens here? Negative y values, negative y values. And then at some point there is a turning point and it starts to get bigger, but it's all negative y values until we get to x equals 2, then it's positive y values. Okay? So what's happening at each of the zeros with a multiplicity of 1 is it's passing straight through. It's changing the y values from positive to negative or negative to positive. That's what's happening when the multiplicity is 1. Let's look at the next function. Type in the next function. The 1/50th. So now these had multiplicities other than 1. So when the multiplicity was 2, what is happening at that x-intercept? So the y values are negative, 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 then it's 0. Then the y values are negative again. So there's not really a sign change. So yeah, it bounces up and goes back down. You should have done this in Algebra 2 a little bit. And then what happens when the multiplicity is 3? Well, it doesn't just go straight through it, though. When the multiplicity is 3, it looks like a cubic function. When the multiplicity is 2, it looks like a parabola. That's what it looks like at that x-intercept. So you got to use multiplicity to know how to graph this by hand. Okay? All right, the next one. G of x equals x squared minus 7x plus 12 quantity squared. This one is not factored all the way, so we can't find all of the zeros yet. How can we factor it further? X minus 3, x minus 4. And then where does that square go? I could. Or there's going to be, if the whole thing's squared, then there's going to be 2 of these and 2 of those. And that's going to help me with my multiplicity a little bit. So we're going to write that x equals what number? 3 with a multiplicity of 2. And x equals 4 with a multiplicity of 2. So when you go to do this by hand, and you go to graph it by hand, which we're not really graphing yet, you have to know what that means. So we're just going to sketch a little graph here. When you go to graph this by hand, you have to know the end behavior, which we just did in our homework yesterday. The end behavior. So what is the degree of this function? 4, right? We've got an x squared squared. There's 4 x's total. So if it is 4, then the degree is even. And then the leading coefficient, the number in front, is that positive or negative? Positive. So if we have a degree that is even and a leading coefficient that is positive, it's going to look like this for our end behavior. So these x-intercepts are the ends. They're the ends. From there, it's just going to go like this. But what's happening at the x-intercepts? Is the graph passing through, or is the graph bouncing? It's bouncing because we have a multiplicity of 2. So this is going to be more like bouncing up and bouncing up. And so if it's bouncing up and bouncing up, there's somewhere in between where it has to come back down. It has to. Now, how high up it goes, I don't know. That's where we will use our calculator to find out how high up it goes. But everything else would be by hand. Okay? Next one, let's factor it. Is it factored? It's not factored. How do we factor it? DCF, x squared times x squared minus x minus 20. So x squared multiplied by
minus 5.
So when we set that equal to 0 and we solve for each factor, our first factor, x equals 0. But there's a multiplicity. Our second factor, x equals 5. Any multiplicity other than 1? Then you don't need to write it. If it's a multiplicity of 1, don't worry about writing it. If you do, there's nothing wrong. I just want to save you some time. How about x equals negative 4? Multiplicity other than 1? Then we don't need to bother to write it. So if we were going to sketch this one, we'd have 0, we'd have 5, and we'd have 4. All right? Yeah. And then what would be the end behavior for this one? Degree is what? Even. Leading coefficient is positive. So we know the very ends are going to be going up. So I know over here, it's going to go like that. And over here, it's going to go like that. And we got to figure out what's in between. So what is happening at x equals 0 if there's a multiplicity of 2? There's a bounce. So it's going to go back up. And then somewhere it's going to have to come back down to pass through x equals 4. And then somewhere it's going to have to come back up to pass through x equals 5. To get the end behavior. What'd you say?
-4.
Oh, dang. That was good practice. Now I'll do the real graph. Sorry. I don't know why. All right, so let's try that again. The end behavior is going to be up and up. And so if it's up over here, it's going to come back down, and then over here, no, it's going to come back down, and then it's going to come back up to hit 0, 0. So the parabola part is actually upside down here. That's a way different answer than what I had before. Silly mistake. You're going to get it wrong if you got a silly mistake, right? Sorry about that.
How do you know how far down?
We will use our calculator. So we'll do that in a moment when we actually graph them. Good question. How do you know how far down it goes? I don't know. All right, how do we factor this one? Grouping? Grouping. You have to have a plus sign in between when you group them. So we're going to take out x squared. And what are you going to take out of the second parenthesis so it matches the first parenthesis? Negative 25. When the parentheses match, then you have x minus 4 and x squared minus 25. Is it factored completely?
No.
Nah. So we have difference of squares. And then we can find our factors. 4, negative 5, positive 5. Any multiplicity? No. So what's going to happen at 4 and at negative 5 and at positive 5? Just going to go straight through it. What's the end behavior on this one? Degree is odd. Leading coefficient positive. So, get my numbers correct this time. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So the end behavior is going to look like that. So how can I possibly connect it so it passes through that point that has the correct end behavior? Like that. And again, that's not accurate because there's still more information we can find that we'll do in a moment. Okay. All right, there's some questions. There's some questions in your homework that use this intermediate value theorem. And all you're going to do is you're going to type the equation into your calculator. Let's do it. Type the equation into your calculator. 3x cubed plus 4x squared minus 9x plus 1. And after you type it into your calculator, go to your table. The intermediate value theorem is asking for an interval where there's a sign change for your y values. I'm going to just take a screenshot of this so I can write on it. Oops. So you guys have this in front of you, yeah? So we're looking at an interval where there's a sign change. Your x's should be going up by 1s. If they're not, there's a way to fix it, but I want them to go up by 1s for this. And we're going to look at our y values to see if there's any sign changes on our y values. So looking at your y values, you see right here, I'm going to go from top to bottom. You see right here, there it goes from negative to positive. That means that it's passing through the x-axis if it goes from negative to positive. So between the intervals of -3 to -2, there is a sign change. That means there is a 0 somewhere in between there. I'm writing this in interval form. Do you remember doing interval form a long time ago? The parentheses mean it's not equal to. The brackets would mean equal to. Right? Remember interval form? Totally. Should be. Okay. The next interval where there's a sign change on the y is where? The y's are going from 1 to -1, so the x's are 0 to 1. Are there any other sign changes for the y's? From -1 to 23 right here. So the x's would be from 1 to 2. So it tells us there's possibly 3 zeros. And some of you already hit graph and saw that there's 3 zeros. So that's all you have to do is look on your table. Just fun information. What do you think is happening here? You think it's going straight across? If you're having trouble by falling asleep, you should participate more. If you're yelling out answers, you're not going to fall asleep. Or you can stand in the back if you need to stand. So what do you think is happening here? Where the y values go from 11 to 11. Yeah. It's going to be like a maximum point. It's just the max is somewhere in between these. Yeah. Good. Okay, so there's a couple questions on your homework. You're just writing intervals. All right, next. If you knew the zeros, could you write the equation? If you knew the zeros, could you write the equation? So here we know that one of the zeros is 0 with a multiplicity of 2, and the other 0 is -3. What would the function look like? What's going to give us an x equals 0? X, and then you're telling me squared because of the multiplicity, right? How about minus 3? X plus 3. So these don't have any multiplicity. So we would have x minus 8, x minus 2, and x plus 4. And I ran out of space, sorry. Now there is one piece of information that they're not telling me here. And it's anything about stretch or shrink. So unless there's more information, I'm just going to go with a stretch or shrink. That's just one. But remember, there could be a stretch or a shrink on these. And you'll see that later. All right, if you have a polynomial of degree n that has the given zeros, we have this one. It has a 0 at x equals 9. Then what's the factor going to look like? X minus 9. But this says it has a degree of 3. So how do I make that into a degree of 3? Yep, now it's a degree of 3. All of the zeros are the same, but there's 3 of them. What'd you say?
What is the, so when it's n minus 3, like, if you had like multiple, like x minus 9, x minus 8, they all.
No, not if the degree was 3. So look at this next one. So the next one, there's 3 zeros. So let's write what we would have x first, even though it's written second. I'd still write it first. And then we would have x plus 2, and we'd have x minus 5. But this has a degree of 5. How many x's do I currently have written here? 3. I need to make it 5. It's really up to you what you do at this point. I could do this. 3, 4, 5. That would make 5. Or I could do x, and I could do x plus 2 squared, and then I have x minus 5 squared. And now I have 5 x's. You just have to have all of the x's, the amount of them be a total of 5. I'm going to skip that one. All right, let's do what we're actually going to do in our homework now. This is what your homework's going to look like, these last 4 examples. Now, I did not put spaces in your homework to fill out the leading coefficient and the degree and the end behavior and everything. I just expect that to be in your work somewhere. All I did was give you the equation and the graph. If you need scrap paper to do it, that's fine. Leading coefficient for this first question is negative. It doesn't really matter that it's a 2. It matters that it's negative. And then the degree is even. It doesn't matter that it's 4. It matters that it's even. End behavior. Remember how we wrote like f of x approaches infinity, all that stuff. You should know how to do that, and you'll probably have that on a quiz. You do not need to do that for homework tonight. So tonight we'll just describe the end behavior however we want to. So if it is negative and even, what's the end behavior look like?
2 down.
Right. So you just describe it however you need to in your work.
We just put 2 arrows going down.
Without this,
Yeah, do we need to do that? Okay.
as long as you know it. Okay. Now we're going to factor this and find the zeros. So we've got negative 2x to the 4th plus 8x squared. How are we going to factor that? What's word?
Take out 2.
A negative 2x squared, because we're looking at the greatest common factor. Once I take out that negative 2x squared, does it factor further?
Yes.
Difference of squares. So my zeros, one of them is 0. Is there any multiplicity? Yes. What's my next 0? Negative 2. Is there a multiplicity other than 1? No. How about positive 2? Is there a multiplicity other than 1? So I don't need to write that. So I'm going to go to my graph. I know that at x equals 0, we have a x-intercept. I know a negative 2 and a positive 2. So the y-intercept is going to be 0, 2. Yeah. If it wasn't, how would I find the y-intercept? You plug in 0 for x into the equation. Now, the term relative extrema is just asking us to find that top point or that bottom point that connects all of this stuff. So this is where we would need our calculator.
Wait, so you plug in 0 for x on the original equation?
Yeah. It doesn't matter, but I would do the original for
Yeah,
that one,
it's
it's
easy.
easier, yeah. I didn't really do the end behavior, but you guys know that the end behavior, we kind of wrote it up there, it's gonna look like this. All right, we also know that what's happening at 0, bouncing. So at -2, it's gonna go straight through. So this, you don't need to draw this right now, but these should be things that you're thinking about. We know that this is going straight through. I don't know how high up it's gonna go, and we know it's gonna bounce here, and it's gonna go up somehow, and then it's gonna come back down. We know it's gonna look something like that, because there's 2 of them. So that tells me it's going to look like a parabola if it's squared. And if it's to the first, it's gonna look like a line right there.
So that's it.
So if it's even, it bounces.
If it's even, it bounces. If it's even, it bounces. If it's odd, it goes through.
I'm trying to remember I'm trying to remember this, because I remember
Mhm.
this. But, hold on, so if the coefficient was odd, what would it look like? Like, what would it do? Like, how
The
would you describe it?
coefficient?
Not the yeah, the exponent, sorry.
Well, if it was, so this is odd. So it goes through it.
What, the two?
The-
I'm
That's a
lost.
1. The first one is a 1 because -2, look, doesn't happen.
Can you explain your question better so I
I'm talking
can?
about if it's x squared, I know it goes through, correct?
Yeah,
Okay, or it's gonna bounce.
right.
It's positive. So if it's negative, it's gonna go through, what you're saying.
If it's negative what?
What is the, what is the line gonna do? Exponent is negative, it's not negative, but odd.
It goes through it.
Okay. So I wanna know.
Okay. We'll have plenty more examples too.
Okay.
Okay. All right, so the relative extrema. Go to your calculator and type in the equation.
Ugh.
Now, what you're using your calculator for is to find this maximum point up here. So how do we find the maximum?
Second calc, maximum. And we're going to pick something to the left of it, -3, something to the right of it, 0, and something near it, -2.
So x squared.
Second trace. This is the couple button. Okay? That's where all the fun stuff is. Okay. Mhm. So that maximum point, you're going to write on the screen that says relative extrema. Yeah, I know. I don't know why it looks so good. We're gonna change your window a little bit to see if it flips it all. Change your window and you can see it a little bit better. I don't know why yours looks so bad. I can't, he has the same calculator as you, this looks fine.
We should learn how to trust stuff like that.
All right, so the relative extrema, negative 1.41, comma 8. And then you gotta find the other one too. Did everybody find the other one? Did you go and find? So this one, because of the equation, the way it is set up, this one is symmetric. They're not all symmetric. So we're gonna graph negative 4.418 and then positive 1.418 and try our best to make it look like it does on the screen.
How do you know how high it goes?
I just found it. That's what we just did. Reading that up.
No, plugged it in.
Uh-huh. And then did you do the maximum with us?
Yeah.
Second trace. maximum.
That's the lucky.
What?
That's lucky.
Yeah, that was the y value, yeah. So those are just points that you can plot and connect. All right, let's look at the next question. We don't know. Let's skip this one. This one I did fill out and put on Canvas. It's just not on the video because we're making the video right now. So go to this one here. Your homework will have screenshots that I made on the calculator. I took screenshots of all of them. So these are equations that I typed in, but you have to find the equation I typed in. Okay? So we're going to start by finding our zeros, and then we're going to figure out if there's a stretch by looking at the ordered pair that I've clicked on. So let's find our zeros first. What is this zero? X equals -2. How about that one? How about this one? And this one is 3. Okay. And then is there, wait, you guys need the worksheet?
I mean, you can print it off online too, but might as well take it.
All right, is there any multiplicity?
Yeah, it bounces from -2 to -1.
You see how it bounces here? Here it changes sign, the y value goes from negative to positive. Here it goes positive, 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 positive. So, and then over here it changes, and here it changes. So there is a bounce, there's a multiplicity of 2.
I know it's 2.
Okay, so I'm not going to trick you. It's going to be hard to tell if it's 2 or 4 or 6. If it's 2, it's going to be 2. Like if it's that, it's going to be 2. Okay, I'm not going to make it super hard for you to tell. Okay.
What do you mean if it's that? If it's that little thing?
If it's a bounce, it's going to be 2
If it bounces, it's even.
But if it's,
on these.
so we just need to answer these two.
Just a second. So f of x equals, now, there is a stretch on this one, but you don't know what it is yet. So I'll show you how to find that in a moment. But let's put the rest of our factors in. We've got x minus 2, x, just kidding, plus 2, x plus 2, and then x plus 1 squared, x minus 2, and x minus 3.
This is that one.
What? Okay, so then I put my little cursor on there, and at the bottom it's saying the ordered pair 1, 3 is part of this graph. So in order to find the stretch, we have to plug in the point 1, 3 for x and y. So we're going to put 3 over here equals a times, we're going to put in 1 for all the x's. So we'll have 3, we'll have 2 squared, 1 minus 2 is -1, and then -2. You'll multiply all that out, and you'll get 24. 1. You see where it's written here? That's how it's going to look like in your homework. Yep.
Oh, when you're breaking it, do you know how much power
No. Okay, I just put it in like left to right. The only time I'd pull it out in front of it's just an x by itself. All right, so then a is 1/8. So when we rewrite our function, instead of a, make it 1/8.
So for our home, that's just squeezing that right back.
Yeah, you do not need to multiply it all. You just have to find the stretch. On this last one, we don't have to do the whole thing, but can we just talk about the zeros in the multiplicity? Like this one here, x equals -2, is there a multiplicity other than 1?
No.
No. How about this one where x equals 3? Is there a multiplicity? So this one does not just pass through it.
Like 3 or something.
So this one is odd.
But it'd be like 3.
So we'll go with 3. We'll assume it's 3. We're not going to go with 5 or 7 or 9. We'll just go with the lowest odd. Other than, I know it's not 1. Because 1 would just go straight through it. 3 has a little, it's called a point of inflection, where it doesn't change and go back up, but it doesn't just go straight through. So that would be like, x minus 3 to the third for that one. But we won't finish that one. The filled out answers are on Canvas if you want to go look at any of them. If there's not enough room to do all your work on the worksheet, then use separate paper, that's totally fine.
Right.
Remember, I am available during study hall A. Study hall, you can come see me if you have any questions on this. If you have any questions, feel free to come to class with questions.
What are we doing next? Like, what are we doing Monday?
We don't finish this homework.
We are gonna do on Monday, we're gonna do long division and synthetic division. Remember doing that? Yeah, so I'll reteach that really quick. Oh, I should probably stop this recording.
Or at least we know what we're doing on Monday.
Yeah, if anybody watches it.